Hello guys, today we'll be coding binary search with the Java language, and in order to do binary search on a data structure array, we need the array to be sorted beforehand. We cannot do binary search without the array being sorted, so that's a mandatory principle. The binary search work on the approach of searching the middle element. Like if, for example, in this array, if we are searching for 3, and the first we'll be calculating the middle of the array, which will be 11 here, and in that case 3 is smaller than 11, so we will be then searching from 11 to 1, only this part of the array, and we will ignore this. And in the new array, which will be 5 elements, we will be calculating the current middle element, which will be, I guess, 7 here, or 5, depends. And in that case, we will again see that 3 is smaller than 5 or 7, and we'll be ignoring this part of the array, and we will have a new array diapason that will be searching from 1 to 3 and 5. And again, we will be calculating the middle one, which will be 3, and that will be our target. The best case scenario for binary search will be if the target that we are searching is already the middle element, and this will give us a cost and time complexity. Other than that, the worst case scenario will be the time complexity will be ON or ON. Okay, and if in case the element is not in the array, we should be returning -1 to say that the element is not in the array. Okay, so let's code the solution and see how it works like. So first we will have to get the size of the array as 2 variables, which will be variable left and right, and the left will be the beginning of the array, which will be 0, and the right will be the size of the array, which will be I think 10. 1, 2, 3, 4, 5, 10. So left will be 0, and then right will be the size of the array -1, because the array starts from 0. Okay, so in order to calculate each middle element and continue to do that, we will be using a loop. We will be needing a loop to do that. So we will be checking, doing a loop while the left index is smaller or equal to the right index. And in this loop, we need to calculate the middle element of the array and check if this is the target that we are searching, right? So the middle, how should we calculate the middle? We'll be calculating the middle by summarize the left and right and divide by 2. That way it will be getting the middle element of this current iteration. So we'll be doing the left plus right divided by 2. Okay, so we have a middle element. In that case will be 9 or 11. And what should we check here? We should check if we are stepping on the target element, and if that's the case, then we return the index and we are ending the function. So if the array of this middle index currently is equal to the target that we are sending in the method, then this is the index that we are supposed to return. And this is the return on the function when we are finding the element. If not, then we should check which size of the array we should continue searching, the left part or the right part. And in that case we need to check if the target, if 11 is bigger than this element that we are on right now. Then left will be middle plus 1, so we will be getting the right side of the array, and we will be having a new left which will be the middle plus 1. And if this is not the case, then we will be doing the opposite. The right will be the middle minus 1, and the new array that we will be searching will be from the current left to the new right part of the array. So, and this is this will continue until we find the correct middle, or the left becomes smaller or equal to, or smaller to, or equal to right. And if it doesn't return the element that we need, we'll be returning minus 1. Okay, so let's see this in action. We'll be sending the array and the target, and we'll be searching 3. Let's see in the debug mode how this will play out. Okay, so we have the array and we have the target 3. The array has 9 elements, so the current middle will be 4. Is the 4 of the array 9? It's not 3, so we will be continue and check which size of the array we should continue looking. Since the target is 3 and the element is 9, we will be getting the left side of the array, and we will be calculating the new right. So the left continues to be 0 and the new right will be 3, so we will be continue to check this side of the array from 1 to 7. Okay, so the new right is 1, and it is the array on index 1 equals 3. That is true, and this is our answer. But maybe I should have printed just to be easier to see. Here the index is 1. Okay, so let's try element that is not in the array, which is like 65. What will happen here? It will basically go to first this part of the array, then this part of the array until it gets to 19, and see that 19 is smaller than 65, and we'll break the loop and it will go to minus 1 because the element doesn't exist in the array. Let's see it in action. So the current middle is 4 and the target is 65. Since the target 65 is bigger than 4 than 7, we will go, the new left will be recalculated. Left 5 and right 9, which is I think 11 to 19. Again, the new middle is 7. Again, we see that 65 is bigger than 15. We are going to recalculate again left and right. Again, the middle, left, right, left 8, right, middle is 8. It's 65 is bigger than 17. We are going again to left recalculation. And this will be the last iteration, that where basically left and right is the same thing. The last element that we possibly gonna check the 19, and we are seeing that it's not, and the left gets +1, which will break the loop and will be returning -1, that the element is not there. And I think the best case solution was this element, that is the first middle calculation, and this will give us the constant time complexity. So let's see. So again, the left is 0, right is 9. We are getting the middle, which is 4, and this is the fourth element. We are searching 9 and should return on the first check and the index that we are searching, and this basically becomes constant time complexity. Okay, so this was the binary search. I hope you like the video. If you like it, please give me a like, and I will be sharing this code in the GitHub in the description below. Thank you very much.